Today we're going to be talking about one of the groups of organisms within an ecosystem that probably, without a doubt, makes up most of an ecosystem and holds a role that is irreplaceable. So there's no other organism or group of organisms that can do what these organisms do. And the group that we're going to be talking about today are the producers. Producers, we're going to take a look, kind of break down, if you want to be technical about them. Producers are known as autotrophs. And an autotroph is defined as an organism that can capture energy from sunlight or chemicals and use it to produce food from inorganic compounds. So this is also known as a producer. So with an autotroph, what we're looking at is we're going to break this word down into its prefix and then this root word here. Okay, auto or autos means self. Okay, it means self. So when something is automated, okay, it runs by itself. And then troph technically means nourish, or where you get your nourishment from. So self-nourish, I always say self-feed. When I talk about trophic levels, I'm talking about food level. Well, you can also say nourishment level, like where are you getting your fuel from? And autotrophs or producers are getting it from themselves. So these would include things like plants, algae, sulfur bacteria. Those are the ones that would be using the chemicals to break it down. They're chemosynthesizers. So they don't need any light. And I just want to make a distinction there between the photosynthesizers and the chemosynthesizers. So the photosynthesizers, they are using light, most likely sunlight. Obviously we can grow plants indoors and that sort of thing. But in a natural environment, they're going to be using light from the sun. And for a long time, scientists didn't know that life was possible in areas without light. We went into areas, like the bottom of the ocean, and we went into cave environments, and we were quite surprised what we saw there, because we saw chemosynthesizers, which were organisms that were using the energy inside of chemical bonds to produce their own carbohydrates. But the end result is the same, whether we're using light or whether we're using chemical compounds. The end result is we get carbohydrates, and that's what we need in order to fuel environments, to provide the energy within an ecosystem, which is what these producers do. This is what they can do that no other group of individuals can do. There's a lot of energy out there, and we've talked about it before. There's energy at the producer level, and there's energy at the consumer level, and there's energy everywhere. But producers have the ability to harness that energy and convert it to something that we can use. I've talked before about energy currency, right? So light is all around us. If we go outside, there's the sun shining, and light is available to everyone. But if you or I were to just lay in the sun, all we're going to do is get a sunburn or perhaps a suntan, depending on our skin tones. But we can't use any of that energy, right? It's blasting down on us, but it's useless to us. We rely on producers to take that solar energy and convert it into something that all organisms can use, okay? And that's food. We're going to take that energy and we're going to convert it into food. We're going to convert the solar energy and get calories out of it, get energy out of it, power muscle contractions, our ability to move around, our ability to repair ourselves and grow new tissues and all those other types of things. None of that's possible without this group of producers that is converting the energy for us. So it's really important. Like I said, they're irreplaceable within an ecosystem. If we were to take away the sun, and the sun just went out, okay, there would be food available for a while, okay, but once we went through all of our reserves, that's it. There's no more food available because everything is dependent on the sun. Even if you're eating a bag of chips and drinking a pop and it's junk food, right? That still came from the sun. The energy that is in that food that you are eating, that is in that pop that you are drinking, that came directly from the sun. You can't have calories without it. So in a sense, we are all solar powered organisms, right? Even though we're not directly powered by the sun, we are indirectly, the reason that I'm standing here right now is because the food that I ate for breakfast came from the sun, right? In an indirect manner, but it's all about those calories. So with the producers, we talk about like how much are they producing, and we actually measure that. We call it primary productivity, right? Because it's the first stage, so primary, and then how much are they making, the productivity. This is the rate at which organic matter is created by producers. And depending on what ecosystem we are in, we're going to see different rates of primary productivity. So all of that is going to be regulated by the amount of available nutrients in that ecosystem. So if there's a lot of nutrients and a lot of water and a lot of resources, you're going to see a high rate of productivity among those producers. If none of those things are available, you're going to reach a point where it's zero. Okay. I know I use terrestrial ecosystems a lot, but I'm going to kind of switch gears here and talk a little bit about marine ecosystems. So in shallow areas of the ocean, so coral reefs, estuaries, areas where the water is, the level of water is low enough for the light to penetrate, we have an enormous abundance of life. There's life everywhere. Like if we look at a coral reef, right? The coral reef is just below the surface of the water, and the light penetrates, so you have organisms that are growing on the bottom of the ocean. They're producing food for fish that eat them, and then you have larger fish that are eating them, and the food chain just goes on and on and on. Okay. And so you have a really high rate of primary productivity. There's production everywhere. And since there's producers everywhere, that means there's herbivores everywhere, and then there are other organisms trying to eat those, and it's just life seems to be never ending in an area like that in the ocean. In contrast, if we go to the middle of the ocean, okay, we go to the middle of the Atlantic Ocean, and the deepest part of that ocean, life is almost non-existent. Because the ocean is so deep there that light doesn't penetrate past a certain point. We hit kind of what's called the twilight zone, and so that's where the light kind of starts to disappear, and then after that it's just completely black. And the surface of the floor of the ocean is several thousand meters below that. So there's no life. There's nothing that can grow there. There's nothing to anchor. Those plants can't anchor themselves to anything. So really, in the middle of the ocean, you don't have a lot of activity. You don't have a lot of like large sharks and large whales. If there's whales there, it's probably because that's part of their migratory pattern and they're just moving from one location to another. But as far as staying there, if I'm an organism, there's no incentive for me to stay there because there's nothing there to eat. So, and the reason there's nothing there to eat is because there's no resources, there's no nutrients, there's no growing surface. So just like on land, if we look at an area like that receives a lot of rain, like a deciduous forest, we have lots of trees, and we have lots of squirrels, and we have lots of rabbits, and all these other organisms, and we compare that with a much colder area like the tundra, where the ground is frozen a lot of the time and those resources aren't available and there's no nutrients in the soil because the soil is frozen because it's in a state of permafrost, then we see a lot of difference between that primary productivity in those two ecosystems. Producers obviously have to have water, sunlight, and nutrients. That's something that we don't talk about in the photosynthesis equation, but plants rely on nutrients. Just like you and I rely on nutrients, right? It's one of the reasons we try to eat a balanced diet, and if we don't eat a balanced diet, then we're, taking multivitamins or some way to supplement those nutrients that we're not getting. And plants are no different. Now, plants have the advantage of most of those nutrients are going to be brought to them through the soil. And if the decomposers are doing their job, they're taking dead leaf litter and animal remains and all that stuff, they're breaking it down, they're decomposing it, and they're releasing those raw nutrients back into the soil, which can then be reabsorbed by the plants. But there are areas where this is not the case. And you have some areas around where ecosystems just kind of become nutrient poor. One example would be if you have a lake that becomes unhealthy and that lake dies off and becomes like a bog type area. Bogs are notorious for their very nutrient poor soil. And so because their soil is so poor, you don't have a lot of plants there. But some plants have found that that's just what they need. So in areas where you have nutrient poor soil, you are much more likely to find carnivorous plants. Things like Venus flytraps, pitcher plants, and sundew. And what they're able to do is they're still photosynthetic, but in order to get the nutrients that they need rather than pull them from the soil because they're not there, they will capture like organisms, and it's usually flying insects and things like that that come along. So maybe flies or mosquito larvae or whatever the case may be, whatever's available to them, they will draw them in and they will capture them. And what they get from that is they get a lot of the nitrogen that is lacking in the soil. So they actually take the nitrogen from those bugs, from those insects, and that supplements what they are missing from the soil. So again, these producers have to have all of these things, and if they're not available, nature kind of finds a way. And in this case, they've gotten really creative, and these plants have evolved in order to catch organisms to feed themselves the nutrients that they're doing. It's not a replacement for photosynthesis. I think a lot of students think that, if a plant's growing, it's not photosynthesizing, it's actually living off of the bug. And it's not. It's capturing the bug to replace the nitrogen that should have been in that soil in the first place. So producers, like I said, they're irreplaceable. They play a critical role in every system. And really, if you don't have them in an ecosystem, you don't have an ecosystem.